Good morning. In this video, we will discuss the Kruskal algorithm to find minimum cost spanning tree for undirected graph, also weighted graph. This is second algorithm for the same purpose, for finding the minimum cost spanning tree for a undirected and weighted graph. One other algorithm we discussed before is Prim's algorithm. This is the second algorithm. So when compared to Prim's algorithm, this algorithm, Kruskal algorithm, is simpler. Okay, let's see one example. A graph is given here. This is a weighted graph, but undirected graph. So you will see the edges where there is no directions. Fine. So let's see how are we going to find the minimum cost spanning tree for this graph. Let's see the table given here. It's not like Prim's algorithm. It's very simple. You will be listing the edges, also the weights, and then the status, like insertion status. And the last row talks about the insertion order. That's not that important, but it's okay. You can have that fourth row also. Okay, so how are you going to fill the table is, first we need to fill the edge and then the corresponding weight, and let's see the status. Status may be yes or no. Tick, you will be making a tick. Okay. How are we going to fill the edges here? Because there are many edges here in the graph. So in which order we are going to fill the edges in the table? Let's start with the minimum weight of the edge. So which edge is having minimum? Let's start from the minimum. You may have, like for example, among the weights 10, 12, 15. Okay, 3, 2, 4, 6, 7. Here 5, 4, 3, 2. So minimum edge, the edge with minimum weight. A to D is the weight is 2. E to G the weight is 2. Here 2, there 2. So how, in which order I am going to fill that two edges, either A to D here or E to G first. Which one I'm going to take first is make in alphabetical order. So just follow alphabetical order, then only we will have a unique solution. Like I solve and you solve, I follow A to D and you follow E to G, we won't be getting a unique solution. The minimum spanning tree, the minimum cost spanning tree may not be unique. So that's what, in order to have unique result, let's have this criteria, filling the table alphabetically. So AD comes first, EG comes later. So let's start with AD. Okay. So the edge is AD. Basically, you can write AD also DA. So I'm not going to. We will put the edge in a form of alphabetical order again. AD. AD means A is the, in alphabetical order. I'm writing the edge AD, not DA. DA is reverse alphabetical order. So I'm writing the edge in alphabetical order and I'm selecting the edges also in alphabetical order. Fine. So AD, the weight is 2, and then EG, put the EG in alphabetical order, not GA. EG is also 2. So this is the like kind of filling the edges. So after finishing this, next I have another edges, 3, like two edges with 3, AB and FG. So AB 3, FG is also 3. And the next is 4, AE and then DF. So AE is 4, DF is also 4. And then 5. Can you see 5? I have only one edge, which is EF, 5. So this is EF, the weight is 5. Then I have 7 here. So anything I missed out? 5, 6. DE is 6. D and then E is 6. After 6 I have 7. BE is 7, and then 10, AC is 10, and then 12, CD is 12, and then what is this? C and F. CF is 15. So you fill in the edges and also the weights like this. After finishing the tracing of the algorithm and filling the table, we just find the final result, the result graph. So what is the result graph? So let me draw the vertices first. So A and then B. What are the vertices present in your graph? Write them, and then we will draw the minimum cost spanning tree based on our findings in the table. So let's say the first one, I already made the entry, but doesn't matter, you just understand. So AD, the cost is 2. I selected, why I selected, it doesn't make any cycle, I selected. See, AD cost is 2, it doesn't make any cycle, I selected. Okay, and then EG, here it is, the cost is 2, it doesn't make any cycle, it's selected, this one. AB cast is 3. It is also, this edge is also selected because it doesn't make any loop cycle. FG is also selected because it doesn't make any cycle. Sorry, the cast is 3. I'm sorry. The cast is 3. AE, the cast is 4. A and then E, it is also selected because it doesn't make any cycle. DF, D and F, if I select this edge, it will make a cycle, so I'm not selecting DF. EF, E and F, if I select this edge, it will create a small cycle here, so that is not selected. DE, D and E, if I select this edge, it will create a small cycle, so I'm not going to select. BE, B and E, if I select this edge, it will create a small cycle, so that's not selected. AC, it is selected because it doesn't create any cycle. After AC, we don't have to continue with CD, CF because all my vertices are connected here. So we can stop here. After we stop, then we just fill in the order like 1, 2, 3, 4, 5, and then this one 6. Leave the rest of the columns empty. That's fine. Thank you.